You guys want to find gold? I'm going to teach you the secrets of geology so you can find it. And along the way, I'm going to give you some of my tips and tricks so you'll be successful out in the field. See those mountains in the background? They produced over 2 million ounces of gold. You have to ask yourself, why did this area produce so much gold? And the secret to that is because it sits on the outer margins of a collapsed caldera. Most of your major gold deposits in the world actually sit on the outer margins of collapsed calderas. Now, why are collapsed calderas a perfect place to find gold? Because they create the perfect environment for epithermal and porphyry deposits. Now, for those of you that don't know what a collapsed caldera is, it looks something like this.
A caldera is a large cauldron-like hollow that forms shortly after the emptying of a magma chamber in a volcano eruption. The collapse is triggered by the emptying of the magma chamber beneath the volcano, sometimes as a result of a large explosion or volcanic eruption. The flanks of the volcano see fissure systems crack and open up as well. If enough magma is ejected, the empty chamber is unable to support its own weight of the volcano ephetus above it. Circular fracture or fault ring develops around the outer edge of the chamber. Ring fractures serve as feeders for fault intrusions, which are also known as ring dikes.
And the reason why that they're perfect for creating epithermal deposits and porphyry deposits, they generate a lot of heat off of that magma chamber. And as it rises, so it creates nice little fractures and fissures in the basement rock. As it begins to cool, steam comes off of it, mostly in the form of carbon dioxide, sulfur dioxide, and water vapor. This is especially true if it's a felsic magma chamber. Now, the way that you get different compositions inside of your magma chambers is for a whole nother video. But just know there's 3 classifications for them: mafic, intermediate, and felsic. Felsic is going to be responsible for the majority of your gold deposits. Felsic is going to be anything high in silicon, like rhyolite, dacite, and of course its intrusive counterpart is granite in the granitoid family. Now, the caldera we're standing in right now is the Silver Creek caldera. It erupted 18.5 million years ago, and it was classified as a supervolcano. It was so massive, it ejected an ash plume with pumice and country rock as far away as Barstow and all the way into Kingman. And in fact, you can still see some of this ash flow in the form of tuff outside of Kingman, Arizona on the interstate. It's called the Peach Spring tuff. Thickest parts of the ash flow tuff was recorded at being 140 meters deep. In fact, if you look up on the ridge here, you can still see remnants of it. Right there. See that white band all the way across? That's part of the ash flow tuff that was ejected out of this supervolcano. Here's a good example of the ash flow tuff that was ejected out of this caldera. Now, keep in mind, after a massive explosion, all that material goes up in the air. A lot of it's going to come right back down. And that's exactly what this is. And this tuff extends all the way to Barstow and to Kingman, if you can imagine how large that is. The only thing we have that's even close to that is Pinatubo and Krakatoa. And those were very minuscule compared to the size of this eruption.
Here you can see the west side of the caldera has completely eroded away, leaving only the east side, which is west of Oatman. In this aerial view, we're looking northwest. You can see the moss mine in the background, which is on the outer margins of the collapsed caldera.
And the reason why I'm telling you this is because if you start looking for these collapsed calderas and you overlay it with MRDS, and then you overlay that with known mining areas, and then a geological map, you're going to see a large pattern start to form. And that will tell you exactly where you need to prospect for potential lode deposits. What you're looking for is any of the fault systems that are radiating out around the fracture rings of these collapsed calderas on the outer margins. And sometimes these fault systems are actually going to cut through it. Those fault systems are the ones that are going to be the richest. We're currently sitting on the Mallory fault line, which extends all the way into Oatman, and it connects up with the Tom Reed mine. This is a hydrothermal deposition model. It has a 75 to 80 degree dip, and it trends to the northwest. The values on this vein start off at 1/4 ounce per ton on the surface, and at 55 feet, it reaches 1.5 ounces. Now, the quartz vein itself is hosted in green chloritic andesite. And it looks like this. It's got chloride in it, and that's important. We'll cover that later. Now, on this vein, you're looking for any iron staining with black specks of manganese oxide running through it. Those are going to be the areas that produce the most gold. Now, when you're sampling lode deposits, there's several ways you can do it. Once you've done your research and you know what you're looking for, you can go around the mine dumps and you can pull out grab samples, or you can actually take chip samples off the vein itself, or what you can do is get yourself a small hammer drill, battery powered, and you're gonna literally drill into areas that have high mineralization in them. And you're gonna collect that up and then pan that directly with jet dry. This area is so rich with gold that they're still mining it today. I'm sure you've heard it. It's called the Moss Extension Mine. It's a large open pit heap leach, and they're getting about 1.5 grams per ton.
The original Moss mine was found in 1863 1963 by Johnny Moss and was so rich that they pulled out $240,000 in gold out of a 10-foot hole. The mine is currently owned by Vertex Mining Corporation and is being developed by open pit mining using heap leaching as a method of extraction of metals. After the blasting cycle is complete, the ore is removed and hauled to a series of crushers where it's brought down to a very fine size of a 1/4-inch mine. The ore is then transported on the huge leach pads where it's leached out using sodium cyanide.
Now, a couple of websites you're going to use to help facilitate locating these places is mylandmatters.org. And the nice thing about that is it's got a feature on there where it has MRDS, so you click it and it'll actually show you those reports. The second one is mindat.org. This is a fantastic site that gives you more supportive information on the mines, type of material they were mining, all this other information you're not going to find on MRDS. It's fantastic and it's very supportive. This is the shaft of the Moss mine. The shaft drops down 800 feet, but luckily there's a plug here so I don't fall into it. You can see that it's cutting this beautiful rhyolite. The host materials were quartz adularia, calcite, and hematite. This is a classic example of the hematite that they were finding that was extremely rich. This is the original rhyolite dike that Johnny Moss found back in 1863. And if you recall what I told you earlier in previous videos, this rhyolite can host some of the richest gold deposits you'll ever find. And I'm sure there's still plenty of gold over here as well. We're on the very outer margins of that caldera. Now, the placer deposits out here are obviously derived from the Lode deposits. Now, for placer deposits, you're gonna look at Silver Creek, and you can see a large percentage of that around Mount Hardy and over on the south side of Boundary Cone, which is a rhyolitic intrusion. But make sure you do your research first to make sure you're not claim jumping, because a lot of this area is claimed up, especially by the locals, and they wouldn't appreciate you coming out here and claim jumping. In fact, speaking of locals, if you do go into town, ask them. Some of them are kind enough to show you exactly where the placer gold's at. Now, I'm sitting on top of a small feeder dike, a basalt dike, and what's nice about these is that they cross any type of a potential gold-bearing wash, and because it's such a hard material, it resists erosion, and it's perfect for capturing fine pieces of gold. So if you're gonna sample, this is what you're looking for. And if I was you, I'd go out and get a nice dust buster, and it's got a trap in the end. That's very important because you don't want all the material to come out. What you're gonna do is vacuum up all these cracks and crevices. When you're running samples, make sure you use jet dry in the water. Very important to break that surface tension, because if not, that ultrafine gold will literally float on the top of that water. Now, if you want to run your chip samples or your grab samples in the field, I highly recommend getting one of these. It's called the Mighty Mill, and we got it from Southern Oregon Prospectors. Thanks, guys. It's great for running small amounts. And I have to stress that again, small amounts. These are not production mills, okay? You'll burn these bearings out and the motor if you run this thing continuously. And don't put something too big inside of these feed tubes because it'll jam up. Now, I got all the samples that we collected up today. I have to break these down so they'll fit inside of that feed tube. So we're gonna run them down and then pan them out and see what we got. Then we're gonna go ahead and pan out this guy right here to see if we got any placer gold in it. So keep in mind, if you're running soft rock like limonite, it doesn't need a screen because you'll plug the screen up fast. But if you're running really hard rock like quartz, put a screen in it. Yeah, you see what I mean? I jammed that screen up because it had some of that limonite from the Moss mine. All right, I'm losing my sun fast, so I gotta hurry and pan this out. And yeah, you're gonna get wet. Yeah, there goes my son. All right, let's take a look. Very, very fine gold. Remember, when you're checking Lode gold, bring a jeweler's loupe. 10 times is perfect. There's definitely gold in it. It's really, really tiny. So what I'm gonna do is I'll put a snapshot up at the end so you can see what it looks like. All right, let's pan out the placer gold and see what we get. See what we get. All right, let's see what we got. Look at that, little tiny pieces of gold. I don't know if you can see it. I'll throw a snapshot of that up too, see it? Little tiny pieces. Look at that, ooh. Oh, and the stopes are massive. I can see why they got excited with this. I'm surprised they didn't finish stoping it out. You can see the drill marks here, and then up there, you can see where the charges actually detonate and fracture the rock. This is the good stuff right here. So that's probably a good place to take samples. More open stoping. This is referred to as an overhand open stope. Here's the hanging wall right here. And you can see where the fault right there is right along the contact zone. And if there's any movement, it's going to create fault gouge. And then you can see where the water comes in down here. And then they were chasing it this way. Do you see that? Got a nice cut to it too. Look at that. Oh, and there's the vein they're following. See this? These are called slicken sides. This is good stuff right here. He's sampling that too. Nice. And this is probably, if I had to guess, goes back to the original vein. See where they're off course right here in these stockworks? And they said, nope, go to the left. Oh, that is good looking material. Look at that. Nice. Ooh, and there's a big something on the floor. It looks like a red worm. Nice, and they chased it all the way to here. You can see why this was 2 ounces per ton. Easy. Look at that. Beautiful vein structure. See that? And they got to here. I don't know why they stopped. I know that World War II came along and it made them stop. But the ore assemblages look fantastic. So that'd be good to drill that, to sample. Fault here and the natural fissures, see how they go up? And this is perfect for those hydrothermal fluids to get up into to make their deposition. See that? And you can see all these different episodes in here. This would be perfect to chip out right here, this little section. That's all fault gouge right in there, that clayous material. That's why they're able to get their roots in there, because it's soft. Fault gouge is typically soft.
There probably is.
Ah, crickets.
Really?
I thought it was a spider.
Coming out of the rock as you're knocking it out. Wow.
I always tell people you never know who you're gonna find out in the field. See that fault gouge, how soft that is?
Boy, it is.
It's
soft.
just powder.
It is. It's just powder.
Then I'm gonna sample other spaces, because you're always supposed to sample not only across the vein, but in different locations.
And the rats and...
Yeah, you're absolutely right. I got a lot of fresh air blowing down through here. This must have been some kind of an ore chute at one time. Oh my gosh, look at that. Oh my gosh, that is huge. A huge cut. I'm surprised they didn't widen this out. Oh my gosh, it's freezing right here. Oh, it's cold. It's cold. Look at that stope. It's a monster. I don't know why they didn't open this up more. Look at that. It's huge. This is the end of the cut. Look at that. Oh, the daylights. You see that? Daylights. Oh, I don't think I'd be trusting that. And this is all the loose wood that's come down. And this is supposedly drops down to 400 feet. Oh yeah, daylights again. Daylights again, why would you? Oh, I bet you this drops down to the 400. And then using this as an anchor. 50 bucks. Oh my gosh, look at that. Look at that. No freaking way. Yeah, everything is just clogged it up. And this is what drops down to 400 feet. You can see that. That is a no-brainer.
I don't have my
Gloves?
gloves and my...
Hard hat on either.
And the stuff on my knees.
Yeah, oh yeah. There's my baby. Squeeze, squeeze. Wow, there's the vein. See the vein up there that they were chasing? So I had to blast out all that waste rock to get to, what, maybe a foot of vein? And we're standing on nothing right now. The chute that we just came up through was bigger and tied into this, but you see this slab right here? The size of a school bus? It broke free, came down right here where we're standing, and lodged in here. Which makes me wonder what I'm walking on. Yeah? Oh yeah, there's that juicy vein. There's the juicy vein. Ooh, what's in there? Water? Yeah, it's water. Look at that vein though. That's what we're here for. That's what we're here for. Look at that. So what they would do is they would drill footwalls gonna first, blast it out, leave the vein behind, and then you can see where they drill directly into the vein, blast that out second. You can see another couple boreholes up there. And that way you don't contaminate your ore, because you don't want to do that. You're going to drop your numbers. So you always blast out footwalls gonna first, get that out of the way, then blast out your vein. It'll fall down onto your muck sheets. Let them know that that's ore, not waste. And you're good to go. Yeah, I know. I don't like it either, but what are you gonna do? Yeah, there's the vein, but you can see that the vein is petering out right here. You see that? Right there, it's pinching. Now, veins can swell back up. They pinch and swell, but I don't know if that's doing any good because they didn't do anything with it. No, I hate water. Can you tell? Oh man, that one's collapsed seriously. Yeah. That one comes up under another stope, but it's all filled in. It's all filled in. It looks pretty tight. Yeah, the vein is pinching right here. There's no more quartz in it whatsoever. It's all brecciated. It's all brecciated. Somebody got brave and they tied this rope up and went down.
Oh my God.
Uh-huh. And this whole slab that you're pushing on used to not be there. Oh, what a mess. What a mess. Look at that, right down into that hole. Yeah. Ooh, my baby's getting ready to go down. My baby's getting ready to go down. There you go. You're doing good.
Oh my God.
Good job. We're gonna try this. Oh my gosh, that's a drop. All right, let's try this. There's a rope catching up. And if you get scared, you just stop. And they have a panic device on this too, which is really cool. Wow, not bad. And they got another working level over there. You see that? Right there. Nice. Oh, there's another working level right there. Oh, that's cool. Oh, look at the daylight up there. You see that? Looks like I've got another working level. Oh, and there's some more. Oh, there's some rail down there. Oh, that is so cool. I don't know what's holding this false floor up. A little sketchy. I got a manway right here. It's actually not a bad ladder. You just got some headache makers down here. You see that? You got some headache makers. Like that one. Oh yeah, look at that. Nice. What is that? These are not exactly the best ladders to be going down. This is just all choked out. Look at that. The rock is really soft. Oh my gosh. Oh. I'll tell you what, you get a workout doing this. That's nice. You touch the rock and it decides to move. Wow, look at that big giant chute down there. Look at that. That's definitely level. You can see where they're using that chute to fill up the skip car. So they would dump everything from here into the ore bin down there. Oh my gosh, the ladder. Oh, the ladder disappears. What do you know? Look at that. Oh, it keeps going too. Oh yeah, that's what I'm talking about. Yeah. Okay, let's see what we got here. Oh, look at that. There's an ore car buried in there. You see it? It's upside down. It's just a box though. There's a level right there. This is probably the lower level to pull all the ore out. If I had to guess. Yeah. There's some dynamite boxes. There's a good ladder right there. Look at that. Ooh, that one's all choked out. It's all plugged. It's all plugged. Let's take a look. Some of that beautiful ore. Some of that beautiful ore. This just goes to a chute. This is what they filled up to get over to here, and then they would dump there, but that's all plugged. Look at that. It just keeps going down and down and down. Got a bunch of newspapers. I wonder if I can find a date on these newspapers. See if I can find a date on these newspapers. This is all choked out. Those stopes have probably all filled most of these in, if I had to guess. They're just massive. Hey, look at that. Jeff, 1941. What do you know? I was down here before. Look at that. Isn't that a cool shot looking up? It goes all the way down, keeps going down. I think I got a drift back there somewhere. I gotta go check that out. It's not exactly the most stable. Alright, we're gonna go check it out. These rungs look really bad. I want you to see this rung. Look at this. There's my finger for size comparison. You see that? It's only that thick. That's how far worn it is. Alright. Let's see what we got. Alright, I've got no ladder at all. So I gotta figure out how I'm gonna do this. The ladder's all busted up, got rocks everywhere. Looks like this was another drift right here. See that? Oh yeah. Look at that. Looks like that goes somewhere. Gotta find out. There's that ore they're chasing. Right there. Oh, I hate that. Oh, looks like they were gonna drift that way instead. Yeah, I don't like that either. Looks like someone's been throwing rocks down here. I guess that's the bottom. Yeah, that's the bottom. Oh wow, you can see where people have been scurrying down through here. I should have brought my dust mask. Yeah, right there, see that? There's the drift. Oh look, there's an ore car. Look at that. Yeah. That's how big the hole is. There's the ore car. That's the end of it. No, this one's choked on. Yeah. Looks like they were gonna stoke that out, but they never did. Look at those timbers down there. Look at that. Beautiful carbonates and silicates of copper all through here. Somebody's been hacking this stuff out. Yeah, look at that. Ooh-wee. Are those stopes big enough for you, huh? Some more pillars. Now you have jack legs that are used for drifting. Look at that. And then you've got stopers, which are only designed to drill straight up. That's their only job. Ooh, that's a huge stope. Yeah. Man, there's just stalls everywhere. There's a massive, massive chamber below us right now. Look at that. And up above, look at all those stalls. Look at all those stalls. That's just insane. And there's the mine we were at. Look at the size of the mine dumps. Isn't that nice? It's huge. So we're gonna pull samples from this area and see if it's got anything in it. And later, we'll show you what kind of gold comes out, if any. And at the end of this month, we're giving away a brand new Gold Monster 1000 metal detector. I'm sure a lot of you guys know about that. But what you didn't know is that we're also giving away a brand new Keen 140S dry washer with hose and gas-powered backpack and a Keen puffer dry washer with electric motor. All you need is a solar panel. You run that thing all day long or night for you guys out there doing those night runs. And of course, as always, we give away the 10 bags of incredibly rich pay dirt, and each bag comes with a 1 ounce silver bar. And I'm telling you, these bags are world famous. There are no bags out there in the world that are richer than these. They look something like this. Now, if you guys want to get your hands on any of that stuff, all you got to do is look for the little icon of the video that looks like that. Click on it, make a $10 pledge, and you instantly qualify to get your hands on any of that stuff. And next year, we're going to be giving away the Gold Monster 2000 and the Keen Rock Crusher. I know you guys want to get your hands on that stuff. And if you got any suggestions on stuff you'd like to see us give away, leave that down in the comments. Because if it's doable, we'll give it away. Except for a brand new airplane or side-by-side, Max. And I'll see you on the next video. Smash that like button.
Magical!
Yeah, I love that.